Hello and welcome. My name is Richard Webb. I am from CSS Insight, where I am the Director of Network Infrastructure. Welcome to today's panel as part of the 6G World 6G Symposium. Our panel today is focused on the topic of network ownership centricity, moving towards service-oriented networks. And it's my pleasure to welcome you to that today. So what are we going to be looking at? Well, we're already seeing movements in the market that suggest the dominance of business models based on owning and operating a network beginning to shift a little. So we're going to be really talking about building networks for now, but also for the future. How should we build them? Who should build them? What are the technical criteria? What does the commercial landscape look like? What about the value chain in the market? What are we going to be using these networks for in terms of work, education, entertainment, administration, and so on? What's the role of network infrastructure and internet-based services in our societies? So this session is really going to explore those relationships between the business models, network evolution, competition, also investment, looking at it from a society perspective. And I hope we're going to have a very lively and very stimulating panel. I certainly expect so. We've got a real panel of broad and deep expertise in communications technology, all of whom are going to bring their own unique perspective to the conversation today. So I'm going to just briefly introduce each of our speakers in a moment, but tell you a little bit about how the session is going to run. Each of our speakers is going to present a few slides just to set the scene and give you a little bit of a flavor of how they are looking at and approaching their area of interest within this broad topic area. And then after sort of 45 minutes mark or so, we will open to questions, but you can ask questions at any time during those presentations. Just use the Q&A part of the webinar interface, and I'll be looking through those questions and pick a few towards the end. So please do engage with us, do ask questions, do keep that, that flow of questions coming, but we're going to kick off with our presentation. So before I do that, just to tell you who we've got on the panel, we have Gavin Horn, the Senior Director in Wireless Research with Qualcomm. We have Volker Ziegler, the Director of 6G and Digital Transformation Research with Bell Nokia Labs. We have Heikki, a Professor of Network Economics from the University of Aalto. Hans-Jurgen Zepernick, Professor of Radio Communication at the Blekinge Institute of Technology. Professor Dr. Paul Timmers from the European University Cyprus, part of the Oxford University, and is also CEO of Iivii. So to get us underway, I'm going to turn to Gavin Horn from Qualcomm to present our first set of slides. And Gavin, it's over to you now, and take it away, please. Thank you, Gavin.
Thank you, Richard. Next slide, please. So I'm going to give you a brief discussion about key technologies enabling the path towards 6G. It feels like I just gave the same talk about 5G, but next slide, please. So if we look at how technology has evolved over the last 30 years, we've seen that there was obviously a big transition towards digitized mobile communications, the switch from analog to digital, which enabled an ability to have inexpensive communications. And then the next transition was allowing us to basically have a handset that was a computer. So we had all the multimedia, the mobile processors, allowing us to basically redefine how computing worked. And then more recently in 5G, we've seen that now 5G and wireless is now transforming industries. We're basically seeing new kinds of industries, vehicle, robot, drones, all being connected wirelessly. And obviously we're going to see a continuation of this change between connectivity, compute, and storage over the next transition as we move towards 6G. Next slide, please. Now, 5G itself is still in its infancy, but it's definitely had a very fast transition as it's been deployed. So we've already seen over 140 operators are using 5G commercially. Another 305 have additional plans. We see expecting 750 million to, and then 1 billion in 2023 phones deployed. We're expecting billions of phones to be deployed over the next 4 years. And already there's over 800 designs. So we're obviously seeing much faster transition to 5G than we saw for 4G across these different industries as well. And so it's much faster. And so obviously that's going to also teach us a lot about what's going to happen and what we would expect to see as we move towards 6G. So if we look, next slide, please. So if we look at what's actually happened in 5G and how it sort of evolved from a technology point of view and how it's sort of moving towards these new types of deployments, Release 15 basically gave you the fundamentals, and that's actually a lot more than the original 4G had. It had a lot more abilities and a lot more capabilities. But Release 16 and 17 then are now moving. We're in the middle of Release 17. They're moving towards expanding 5G towards these new types of use cases. So obviously mobile broadband, millimeter wave are continuing to evolve and new features being added. But we're also seeing new types of deployments such as unlicensed and shared spectrum to enable things like private networks and allow you to move more toward the edge. We're also seeing new types of technologies like V2X being added to 5G, as well as industrial IoT, massive IoT, and of course broadcast. So all these new technologies are then being added to 5G to allow these new types of deployments. And then of course, as we move to to Release 18, which is currently in planning and is expected to start around early next year, we were going to continue to see this evolution, as well as new types of deployments and new kinds of use cases that 5G will address. And obviously those will then move towards things that 6G addresses. Next slide, please. So from a deployment type of view, we're seeing some very interesting things, especially as how cloud has evolved. So obviously initially cloud was basically a centralized thing, but now it can't scale. The amount of data that is being created is too big for cloud to scale. And so we're seeing a big move towards the edge. Now cloud's still going to have an important role in the indefinite future because it's obviously fundamental to training, even for ML AI use cases. All the data is going to happen, a lot of data is going to be trained in the cloud. But now we're moving more towards these partnerships where we see a massive amount of data is now being processed at the source. So we're seeing now these devices that are on-device AI inference and all these new types of use cases that are much more edge-centric or device-centric. In the future, we expect this now to become a much more integrated platform where you have lifelong on-device learning, and we also see the next level of personalization and with privacy as data and cloud converge to this new harmonized platform. Next slide, please. So what is the data in that platform? So obviously we're seeing the emergence of these three worlds. So I guess 5G had in IoT, URLC, and massive mobile broadband. It had the three corners. 5G as towards 6G, we're looking more like how data is evolving. So we see this digital world, which is essentially all these sensors and all the other information that is being collected as we move to as data is more available, and obviously how that data is going to be handled is a fundamental change in how we interact with the world. And of course, the virtual world is VR, XR, and all these different kinds of realities get added. So we now see more spatial computing, and we see how our own reality is being augmented. And obviously, the handling and processing of this data is going to be a fundamental way that 6G is going to shape our world. Next slide, please. So what are the underlying technologies? Obviously, the 5G had this, 5G had this basic foundation. We had a much more flexible slot-based framework. We had the scalable numerology. There was a lot of changes in how we designed the 5G PHY to enable us to have a much more flexible system. But we also had more things like network slicing and types of network architecture options to make it more flexible to these different kinds of deployments. And so as Release 16, 17 has happened, we've seen, again, expansion of these and allow us to use these new types of use cases, including extended reality, low capability devices. But we've also seen enhancements in the actual abilities of 5G. So we've gone towards more high precision positioning, as well as moving towards much more higher bands. And we expect this to continue within the Release 18, 19, 20, as well as we move towards 6G. So we see things moving towards like AI, ML, data-driven design. Like, can we actually design with the data, based on the data we're seeing? We're seeing things. We're also looking at things to improve capacity, like full duplex, high millimeter wave, etc. And basically looking at the next foundational technologies as we move to 6G with the waveforms, multiplexing, channel code, MIMO, and all the cloud, and how this evolves towards a platform that is going to be even more flexible and more data-driven than 5G was. Next slide, please. So we obviously, as I said before, we're going to see this continued evolution, and basically we're looking towards how we connect our world. How do we basically focus on this use case expansion? How do we learn from our new deployments, and how are we going to basically expand towards what's called leveraging data and leveraging AI and ML towards basically creating a world where a technology platform for 6G. And so this is obviously going to evolve. And so 5G will evolve in the next few years, and 6G then will start in the same way, similar to how 4G, the 4G to 5G transition. So we will expect to see that new things coming up in release 18, 19, and 20 will then be the fundamental platform for which 6G will be based on. Last slide, please. So as I said, we're sort of now in the initial deployments. We're basically at the very beginning. We expect obviously to see then more broader global deployments. We expect more bands, more capabilities. And that's another thing that's going to change in the next few years is the actual device capability is going to improve. And so we're going to learn from these new devices. We're going to be able to do new things. Obviously, deployments are going to help us a lot. And so as these new releases, new markets thing, we will then shape this vision towards research and standards towards where 6G is going. And so that's sort of where we're going to see. And this obviously is going to shape how the networks get deployed, what kind of technologies get deployed, and what kind of use cases are available. Thank you, Richard.
Okay, thank you very much, Gavin. Interesting stuff there. And a good reminder, I think, that 5G is really an umbrella term. It means an awful lot of different things. It's not really one absolutely unified technology. And I think we'll be getting into some different aspects of what that means, not only for 5G, but as we look to 6G later in the panel. But now on to our next presentation session. And this will be from Volker Ziegler from Nokia Bell Labs. And Volker's going to talk about human possibilities as a service. So Volker, over to you. Thanks.
Yeah, thank you, Richard. Ladies and gentlemen, it's a pleasure to talk about 6G in the context truly of driving growth and sustainability. But what is really exciting, and it's at the heart of our vision at Nokia Bell Labs, is to expand human possibilities, and what we will explore as part of this session, and I will share some insight and thoughts, is elements of context and what the service-centric paradigm might actually mean in terms of business model implications, and also on-demand agility, scalability attributes. Before we go there, just to reiterate briefly, 5G is on. It's important. We at Nokia, I'm happy to share, we have won something like 160 commercial contracts in the meantime, and we have 8 more or so years to go. And just to be clear, we have just seen the beginning of the potential of 5G unfolding in terms of, we started with mobile broadband services, for the most part non-standalone, now increasingly, of course, also rolling out standalone solution, and thereby enabling a whole range of new possibilities. And as now we move into the next several years, expanding use cases indeed for new verticals, manufacturing, industrial, and attributes of performance that will be powerful dimensions of ultra reliability, as well as neutral host private network context. But with this, next slide, please. Let's talk 6G, and let's look at human possibilities as a service. And truly, the evidence seems to suggest, we at Nokia Bell Labs at least are confident from the early research that we now have done for 2 years or so in terms of framing the agenda for what the next generation might be. Yes, indeed, 6G will be, there's a good likelihood for it to be something like the enabling foundation, right? And when you look at this slide, you see elements of society pull, it's like the middle part of the slide, and the elements of technology push. So society pull, creating value in terms of use cases and human-centric by approach and nature. So it's all about use cases that are centering on performance attributes and value attributes that go beyond what 5G can do. We at Nokia Bell Labs, by the way, it starts with a vision of connecting the worlds. And so what we see is physical world, digital world, but also the biological world. Biological world is important in terms of how the way we interface with humans, and that in itself also will open up a whole range of new possibilities. Just looking at some of the use cases, high level, to sharpen our sense as to what this might be about. Let me start with telepresence. You know, Richard, everybody, this session is cool. At least we can talk and we see each other, we share a slide. But of course, what we would really want, well, first of all, meet physically, meet up in a physical way. But maybe another option would be to have like holographic, deeply immersive experience, three-dimensional, and not just this kind of flat screen Zoom kind of experience, which is not bad, but still. But then when you look at other use case families that go beyond telepresence and thereby creating new digital worlds, it's, I think, one of the most exciting family of use cases, and we could discuss these for a long time. It's really about what we at Nokia Bell Labs have framed as creating the sixth sense, right? It's if you like, creating a permanent overlay of artificial intelligence in conjunction with network. And to say this up front, and this is very powerful, it's about technology push. One of the cool, truly disruptive elements of 6G technology ambition and research ambition really is that we would design networks not only for communications, but also for sensing purposes. Pretty powerful. And then, of course, kind of some more indicative use cases of interest, drones and robots, the way we control automatons, again, going beyond what 5G can do and some of the performance attributes. And last but not least, let's maybe also look at application areas such as health, in-X networks, nanoscale, even body monitoring kind of solutions, scenarios. Why not? Powerful opportunity to indeed expand human possibility. And all this against the background of technology and research agenda. Just to be clear, at this stage, what we really do is we frame the agenda for research. And on the timeline, we only expect like 2024, 25, and beyond early standardization and dissemination activities kicking in. In terms of technology, just very brief, the big themes really are ubiquitous compute. So 5G evolution is on. So we do see a massive transformation to software, cloud native architecture, microservices architecture, distributed cloud, and of course, automated management of resource in a broader context. And what we foresee for 6G actually is very exciting, because ultimately it means that we would anticipate convergence of what today is radio network and core network. So even the upper layer of radio going microservice. Precision sensing and actuation, another powerful dimension of technology, and very powerful, in particular in conjunction use case for industry. And again, with performance attributes beyond what 5G can do when it comes to like precision in the really low centimeter range. Knowledge system, pervasive AML, I already mentioned that. I think it's one of the key drivers really. And last but not least, yes, indeed, it's about how we interface with machines and how we would more effectively, therefore, also expand human possibilities, and typically as a service. Next slide, please. So this actually, ladies and gentlemen, is an attempt at looking at some of the contextual elements of the business environment, of what services-centric paradigm might mean and what's kind of new. And what you see here is on the upper left-hand side, like kind of contrasting network versus service on the one hand side, and customized offering versus more standardized offering. And very clearly what we see is a trend towards services, as well as truly, some folks would call it long tail kind of customized offering big time. And this actually is starting with a 5G evolutionary trajectory. So as an architect, when you look at this, of course, many of you are aware, service-based architecture, service-based interface paradigm is already happening as we speak as part of 5G. And now as we move into the era of 6G, probably we'll see a lot more of platform elements across heterogeneous cloud infrastructure, including aspects such as cloud capability discovery that allow you to customize more, not to mention what's happening with 5G evolution in the spirit of, and with the technology of slicing, thereby truly tailoring the offer and optimizing it to the use case. New players coming up, yes, possibly open ecosystem paradigm, also powerful option in terms of moving into the 6G era. So this again ties into technology change, open API, and the fact that, of course, yes, indeed, we will see a lot of softwareization and across the architecture. And then probably what also needs to be highlighted as part of the 6G paradigm unfolding is really performance and value indicators. So just indicatively, throughput is talked about a lot for the right reasons. You need it for the telepresence. You will need a huge bandwidth in the tens or even 100 gigabit per second range. Latency reliability, pushing the envelope down to 0.1 millisecond. Scale and flexibility, by the way, another interesting one. So on the one hand side, it's about connecting the unconnected, So really going global coverage, and on the other hand side, it's about densification to the extreme. Some of that has started with 5G, of course, small cell paradigm 5G, but then with 6G, we would expect something like 10 million devices per square kilometer. Pretty exciting stuff. And all of that, of course, creates value if you get it right in dimensions of both growth, sustainability. Next slide, please. So last perspective I wanted to offer to help set the stage is a decomposition of what the elements that kind of shape the business model for the 6G era, and in the context of a service-centric paradigm. So what you see on the left-hand side are key input parameters shaping the business model for the 6G era, for the 2030s, kind of broadly clustered into opportunities, value, and advantage. And if I'm to highlight maybe only one or two aspects that kind of stand out, there really is, on the opportunity side, I think, iconically coming up with 6G era, this whole notion of specialized networks. Why? Because we will be able to really tailor performance attributes such as latency, reliability to the extreme, also throughput, other attributes. I think that's clearly one. The other disruptive element on the value side, already mentioned, is maybe the option to design networks, co-design networks for both sensing and communications purposes. This would technology-wise then tie into a whole range of interesting engineering challenges, such as waveform multiplex. I think, Gavin, you had hinted at that. And then on the advantage side, probably security, privacy, and trust, very important also to mention briefly. And then on the middle part, right-hand side of the slide, you see key attributes really shaping and describing the business model in terms of scalability, growth, replicability, and sustainability, efficiency aspect. And there, I guess, service agility is probably one aspect that really stands out, extreme flexibility and time to market. But then on the sustainability and efficiency side, let's make sure what we do here really creates value for society in dimensions such as digital inclusion, but also protecting user privacy. On the right-hand side, just to wrap up, you see some examples as to what service centricity might actually mean in terms of offering 6G as a service, broadly speaking, use cases, AI, trust, even distributed ledger, DLT, blockchain kind of offerings. So that's why we believe at Nokia Bell Labs, powerful options, business model transformation for the 6G era coming up. And with this, I go over to you. Thank you.
Thank you so much, Volker. Really interesting stuff there, and a really nice way of kind of outlining the 6G ecosystem, but also giving us a kind of future-looking context as well for some of the service and network environments we're going to be talking about in a while. Just one point before I pass on to our next speaker. I had a question in about whether the slides will be available. The whole archived recording of today's panel will be available via 6G World, so you can look at the whole recorded version and the slides on via the archive setting through 6G World after we've wrapped today. Okay, so on to our next speaker now, and it's the turn of Heikki Hämmäinen from University of Aalto, who's going to give us a few little kind of thought stimulators about network capabilities and some of the kind of technical considerations for 6G moving forward. So Heikki, over to you.
Okay, thank you, Richard. Hopefully you can hear me. I've had some connection problems, but let's hope for the best. Yes, so a panel teaser. Maybe you can take the next slide, please. And my talk is kind of starts with a introduction from a very broad view and focuses then to what I think is relevant for the topic of today. So we can see that there are two major evolution paths: the internet path and the mobile path to the current situation. And if we think about what has happened with internet, so we know that internet was kind of a simple paradigm of an open network, end-to-end connectivity and programmability. But what has happened after that is that we've got the firewalls, we've got the content overlays, and cross-layer optimization in wireless access and so on. So actually the original paradigm has become quite complex lots of functionality and intelligence has moved from the edge to the network, or from devices, hosts to the network. And then if we look at what has happened with mobile networks, we can see that there's been a transition from this kind of monolithic environment of mobile network operators to supplier-operated MNO networks, which is kind of clear indication that the mobile operators have become gradually more interested in services compared to the nitty-gritty of the network itself. And another indication of this trend is this outsourcing of sites. We know this American Tower, SPA type of operations and so on. So there are operators in many countries who have actually, maybe because of need of money or for various reasons, other reasons, to kind of sold ownership on sites. And it's interesting to see how that develops over time, because it's maybe also a regulatory question of what is a kind of national ownership and what can be owned by foreign partners related to critical infrastructure and so on. And now we are seeing the virtualization of cloud and networks, first cloud and now networks. And this is where we are now. And this clearly indicates that there is this kind of trend from networks to services. So there's lots more complexity in the network with services and more of interest and more of value there. So the answer to the panel kind of title and question is very much yes, that we are moving towards services. But then next slide, please. Okay. So the next slide. It's updating. Slides are updating slowly on my screen, but you will hopefully see this situation here. So, okay, now we are too far ahead. Optimal placing. Yes, thank you. Yeah, so now we are kind of in the future. We jumped from history to the future and the optimal placing of computing and storage. And this is mostly a techno-economic viewpoint. And we are clearly seeing this movement from static to dynamic environment and also static to dynamic placing of computing and storage functionalities in the network. And you can see the graph here showing kind of intermediate storage options between the server side and the device side on the left. And what this means, what we are talking about, we are talking about late binding in placement of virtualized functions. And this is very much what is happening with 3GPP specifications as well. There is more and more software related dynamics, which is increasing. And this raises the question that what is an optimal placement ultimately? And the second bullet here is saying that the placement is optimized for cost, user experience, and security. Security is mostly a kind of a constraint. It doesn't really optimize. It's a constraint that somewhere it's good enough and somewhere not good enough. But user experience is a never-ending story to improve it. So it's important to get functionality closer to user for better latency and so on. But then cost often drives to some other direction, getting the scale benefits and so on. But ideally, because different services and different applications, their optimal point is different. We can see that we have actually an extremely complex environment in optimizing all sessions, basically all sessions regarding these dimensions that I'm listing here. And this is what we are often talking about, but we often forget how complex and how difficult this objective is to achieve. but we can see that this kind of future environment, it will be very competitive. From kind of economics textbooks, you can directly derive kind of high level of competition in this type of environment where we have this flexible placement. And we can also easily see legal challenges that this raises. So the legal boundaries, that who is responsible of what, if actually functions are moving in almost in real time from one place to another. So who is responsible of computers, who is responsible of these containers or microservices, and how do we actually define business contracts between actors? Where is the kind of boundary of responsibility between different actors in this environment? This will be extremely challenging. And we can see that these business contracts between actors, they are increasingly driven by technical interfaces, especially software interfaces. And this actually makes it interesting to link the technical architectures and market architectures much closer to each other. This is what we are seeing currently, gradually happening. So engineers and economists or economics experts, business experts need to employers need to get into much closer cooperation to make all of this work. Can I get the next slide, please? In this last slide, we get into the kind of some of the key questions on today's topic. So this 5G, 6G virtualization, we have put a lot of effort on studies on network slicing because I find it quite interesting regarding the ecosystem structure and the virtualization and how the different actors cooperate and compete on the level of mobile platforms. And one observation or kind of assumption is that there is a difference in scope. So when we talk about things that happen between mobile operators, things that happen inside a single mobile operator nationwide, and things that happen in a local private 3GPP network, in a factory or harbor, some kind of industrial campus or whatever, it seems that these dynamics will evolve quite fast in the local environment, and it might probably evolve in a quite different way compared to nationwide and inter-MNO environments. So we need to be cautious when we discuss and kind of make assumptions about the next steps. It is highly dependent on the context. One other interesting question is the number of slice types and instances per network. This goes quite deep, but I think it actually is very much in the core of the problem. So this kind of innocent-looking question that how many slice types do we need, or how many are we going to see, and how many instances of slice types are we going to see in any particular environment? This tells very much about the level of complexity and level of dynamics and so on. And my assumption, my guess is that we start with very low numbers, and then it's this cost-benefit kind of compromise that will define how high it will go one day. And based on these assumptions, it seems that there is lots of network service innovation happening on local level, more than on MNO level, because of the big volumes and all kinds of factors that slow down the evolution. So I would bet on seeing interesting new arrangements happening on very local levels. This was my message. Thank you.
Thank you very much indeed, Heikki. A really interesting set of discussion points that we'll be following up on, particularly around that kind of value chain and boundaries of responsibility and requirements in the network as well. So food for thought, but we're going to go on to our next slide session first before we go into our live Q&A, but do keep those questions coming as you listen. So I'm going to hand over now to Hans-Jurgen Zepernick from the Blekinge Institute of Technology, who's going to give us a kind of walk through, if you like, a case example of an immersive 6G environment. So Hans-Jurgen, over to you.
Okay, yeah, thank you, Richard, for the introduction. Welcome, everyone, and good afternoon. I will be talking about a rather particular network slice, which is an immersive digital value platform with pushes some of the technologies to the limit in terms of latency, bandwidth, computing, and processing power one would be needing, and would start with some graphical indication how it has been going with immersive, in particular with visual interactive computing type of application in a 5G, 6G, and beyond 6G content. So next, transparency, please. Next slide. So that's how it looked like in 2005. It was the inauguration of the Pope in that particular, and you see the audience standing before the event where the Pope presents himself to the audience, and there's hardly anything on mobile devices. You can see is on the bottom right. You see one device which with a mobile, and that doesn't really put so much stress on the networks. I think one could handle that. If you look a few years later, 2030, that will be the next slide. It's like a Christmas tree, and you can see everyone is doing photos, probably downloading it, and it's another type of bandwidth and communication skills one would be needing in order to attach the humans to the backbone to the network. And that has been continuing further with moving out with immersive media from the consumer markets into a broader audience, which will come on the next transparency, please. And this captures quite a bit of topics which I would be calling a reality virtuality ecosystem, where you have several players involved and several mechanisms. One is it's humans involved, which consume these services or these immersive digital value applications. You have human-machine interfaces. In this case, you see the head-mounted displays where people can dive into the virtual world. You see also one person with a hand. You have also the feel of touch, which even pushes further the requirements on latency and bandwidth. And then you have the networks, this web, what you would be seeing as wide, and you have nodes attached to it, where people over this immersive media attached with each other. So with this type of application, you not only go to extended reality, you will have the telepresence, you have digital twins. In 6G, you probably have the resources available for holography. It captures a whole range of vertical industries, from industry to education to health services with car and training and so on. And again, it would push some particular network slice to the limit in terms of latency and bandwidth. So with this reality and virtual ecosystem, we can go to the next slide, which makes it a bit more structured. So we have humans. In this case, we have vision and perception to it. It can be also the smell. It could be also the feel of touch. We have haptics involved, and also the sound, which is not shown here. Then we have the human-machine interfaces. These interfaces need to be intuitive and have intuitive interaction, so it feels as if we would be sitting together. And then we have networks which facilitate all those services and applications around the world with seamless communications, seamless connectivity, and it would provide not only quality of services, but also the quality of experience. So these networks need to, on one hand, work on quality. On the other side, they also need to improve the immersion, which brings us to the next transparency. Next slide, please. And here we come with a paradigm of continuum, reality, virtuality, continuum, with a different level of virtuality. So the first would be the just virtual reality with a completely virtual environment. Then we can start mixing the virtual world with the real world, putting some objects, some data, some spreadsheets into the virtual world. The next would be the mixed reality, where we actually can interact with the augmented world, and all those can be captured by the umbrella term of extended reality. So with those different levels of virtuality, need to have a different requirement on the computing and also the communication. So can we do that on the device, or how do we get the network involved? Which brings us to the next slide, talking about the communication computing continuum. That means we cannot do all the processing due to the complicated algorithms we are running. We will have to outsource something to the networks. We have this concept of cloud, or we have the concept of the cloudlets. We have small boxes, data centers, and we, with our devices, only one hop away from the mobile device. So in the future, probably processing and processing coming being stronger, we can do and have the trade-off between the processing on the device or in the network. And one constraint is the battery power, so we're not running algorithms which train the battery power on the devices so fast. But we don't want to go so much into the centered clouds. We have several units primarily focused to bring the cloud technology closer to the user, which goes a bit away from the network-centric, more to the service-oriented type of network structure. Another one going in even more detail and find a spread out of the computation power is on the next slide, please, where we go from the cloud, we're distributing to the cloudlets, and then we use all the processing we have in those environments wirelessly with the mobile phones, with the body sensor networks or whatever is around to do that process. So it's a paradigm of communication computing continuum, if you like. And on the next slide, please, we can see several parties will benefit from this type of continuum. That would be the mobile network operators, application and service providers with the different vertical industries to serve. We have content providers, over the top players, network equipment vendors, middleware providers, and others would be working in that virtuality, reality continuum, the computing communication continuum. And then the last thought, which might be a bit progressive, but also going into the continuum. This is the next slide, between a continuum network ownership centric to service oriented networks continuum. And there are two question marks in the top bubble and in the centered one. So I couldn't decide where to put the continuum in. So the nicest, like aesthetically, would be that we have the continuum on the circles outside. So the top could be the ownership service oriented network continuum. And then the C would be the reality virtual continuum, and D would be communication computing continuum, and the immersive digital value platform would be the center, but one also could switch it around, that the ownership service-oriented network continuum would be in the middle, and the immersive digital value platform would be on the top. So it's some of an ideas, maybe I also can discuss it later in the session, which brings me to the second last slide with the acknowledgement of the Knowledge Foundation, which supports us in doing this work, part of it which I have presented today. And coming to the last, transparency, coming back to the real world, and that where we are sitting. And I hand back to you, Richard.
Thank you very much indeed, Hans-Jurgen. That's really interesting stuff, and we'll certainly be picking up on some of those points that you raised, particularly around that network continuum and the value of infrastructure. We'll be getting to that in just a few moments' time. But first, the last of our prepared pieces of presentation content for you today. I'm going to introduce Professor Dr. Paul Timmers of the European University of Cyprus, part of University of Oxford. He's also CEO of Iivii, and he's going to talk you through a more governmental and societal perspective on 6G. So, Paul, over to you. Thank you.
Indeed. Thank you very much, Richard. Thank you also very much for including me in the panel. Perhaps I can have the next slide. Because my presentation will be a bit different, as I indeed coming more from a policy, perhaps governmental and academic political sciences perspective. And a bit provocatively, I've called my slide here centered around government happiness. The question is whether governments will be happy with the 6G developments that are going on. And I was kind of struck that looking at most of the slides, you get an image of us escaping or us entering into a new universe, escaping from this planet. You know, you got these pictures where we're actually floating above the planet as if we can enter exciting new universes. And I think we will. We do. There's very exciting prospects. Yet at the same time, the planet is still there, geography is still there, and governments are still there. And governments are bound to geography, and that will still continue to play a role. So is this new universe actually compatible with the way governments are looking at the world? Can I have the next slide? So there's a lot of study happening, very interesting studies around where 6G might go. And if you look at this is something from a number of Finnish authors of 2020, various factors that play a role. And I will focus, if you click once more, I will focus mostly on the political side. Okay, let's click through these. Now, governments are indeed worried, and I think that's a reality that we have to take into account. They are worried about 5G, Internet of Things, microelectronics, artificial intelligence, platform developments. If you click once more, Emmanuel Macron, for example, said in 2019 that sovereign decisions and choices were de facto delegated to telecoms operators. And this was triggered by the debate around 5G security. If you click once more, you see that the Huawei founder predicts that the Internet of Things is going to be the next battleground with the US, who is going to dominate that. And so this is not a neutral technology development and standards development. No, things that's where a real geopolitical battle will happen. Click once more. Also in microelectronics, Halbleiterfertigung, microelectronics, Commissioner Breton said that the European Union would like to be autonomous. I don't think he really said that, but you get the gist of that. So there's an autonomy question there. And then finally, if you click once more, the European Commission recently came with proposals, Digital Services Act and the Digital Markets Act, that are really intended to do something about this dominance of platforms. And they are worried that there are gatekeepers that will constrain the opportunities of businesses and other businesses and of people and citizens. So click once more, next slide. There's a new political reality that will also influence 6G developments and is already influencing 5G developments. There are these geopolitical tensions, US-China, but also Europe, US-Russia. There are other geopolitical tensions, even transatlantic. There is the digital disruption and the dominance of platforms that is for a number of people of a great concern. And of course, we see cyber threats that are increasingly worrying. 5G security perhaps was for some a bit more hypothetical, but you see the supply chains attacks. I just need to mention SolarWinds. You know, there's really serious stuff happening there that indeed altogether add up to a feeling that sovereignty is under threat. Whatever sovereignty is, states are worried. Now let's go through next one. So governments will not sit on their hands. They actually, perhaps they were sitting on their hands. Like Macron said, we left sovereignty to the telecoms operators. What's that? Sovereignty is a government type of thing, isn't it? And it was left to the industry. So governments are saying, no, that's not the way it should go. We should have more control. And for good reasons. There are safeguards that need to be put in place for public interest. And although 6G developments promise that, it's not guaranteed to happen around public interest like environment, inclusion, health, jobs. But let me also mention another one. With all the interconnections that exist, there's also a great worry about systemic risks that, for example, you can destabilize a small part of the system and it will then go through all of the system and destabilize, for example, the financial system, as we have already seen happening. And this can also happen in 5G or 6G communications origin. But it's also to defend sovereignty and build strategic autonomy. And notably, this is where national security is a concern, but also sovereign assets. And what do I mean by sovereign assets? That is, for example, take your health data. That's really data that belongs to us, isn't it? And is there a safeguard that they continue to belong to us in this very open ecosystem, as Heikki also stressed, in this very open environment where the boundaries of countries and the controls on companies and users are perhaps less. And we have seen the worries that is happening around the sovereign assets. The sovereign assets might also contain your domain name system or your other technology naming systems. And then finally, governments are seeking increased control because they want to expand and advance their geopolitical ambitions. And I think we should not be naive about that. There are clear agendas there, and governments are not happy to sit just within their, be constrained by other governments. They have geopolitical ambitions, and that also spills over into standards and into technology work. Okay, let's move to the next slide. A bit of an overview then. If you want to seek more control as a government, where would you do it? In technology R&D, in standardization? Would you try to control manufacturers, providers, the users, especially the business users, or perhaps the usage and the content? And this is probably a slide that you can debate about it, whether it's right to assess it like this, because we don't know exactly the 6G future, but we can expect, I think, that in technology R&D, for example, and in standards, government will want to get earlier involved. And for example, government procurement, government as a launching customer could be a very important innovation tool, but a tool also for governments to have more control on the architectures that are coming out. Where we go from a limited number and more concentration in manufacturers, we might get a greater diversity, but a greater diversity is also harder to control, especially if sensitive stuff like competition, fair rules, security data comes into the play. And the same holds for providers that may get a very important role actually to protect national security, whereas, and business users likewise, whereas before they thought we are just doing our business. Now they get the attention of national security and sovereignty concerned people. And in the usage sphere, where we have mostly vertical regulation and few regulated parties, relatively speaking, in telecoms, for example, very likely regulation will be a mixture of digital regulation, which you might call horizontal, and vertical, so sector-specific regulation that is affecting many more parties that will be classified as critical, many more. So perhaps that's not such a happy future for most of us, but we have to take this into account and see what we can do about it. What can we do about it if I can get the next slide? Well, one thing, click once more, would be an early involvement of governments. And this would be in governance, requirements, specifications, R&D, and standardization. Sounds perhaps very difficult because what is it that these bureaucrats know about technology? But perhaps it's a real responsibility that industry and academia need to take upon them to strengthen this link to governments at a very early stage. More than that, if you click once more, and once more, yeah, I would argue that we need to move into a new way of working between technology and law or regulation. We need to think about co-design from the beginning. Technology architectures determine what you can do as a policymaker. There's the famous book of Lawrence Lessig, Code is Law, where he essentially says the architecture of the internet conditioned, constrained, and determined what we could do with internet law. And it's like that with 5G and 6G. And that's why governments are unhappy, because the architecture of 5G security did not provide them the type of security that they need to have from their sovereignty and legal perspective. So it may be hard to do, but I think there's definitely a paradigm that we need to pursue in order to win the game in a win-win way. And finally, if you click once more, I would say we have to anticipate that there will be more ex ante, so before things are happening, measures, legislation that is happening and conditioning the market, rather than expose corrective measures like competition measures, because governments no longer trust that the 5G and 6G community will be able to deliver more competition and diversity. They will want to see it. And governments also have these geopolitical agendas that may not fit with the global open 6G. In other words, they will try to condition the development of technology and markets upfront rather than exposed through competition corrective measures. Thank you very much.
Great, thank you very much, Paul. Really interesting stuff, and absolutely that geopolitical background context is hugely important and not to be ignored, because as I think it was your second or third slide showed, it does have a real impact on the competitive marketplace for technology. So valuable input, as it was from all of our panelists. So thank you very much for that. So now we're moving into the live Q&A section. I have a few questions to kick off with, but please do keep your questions coming in. We will do our best to get through as many of those as we can. So something that I think quite a few of you touched upon from perhaps different angles was the role of the network operator. And we don't have a network operator on the panel, and it's certainly not our intention to speak for them necessarily, but based on our experiences and interactions with network operators, as we move from 5G to 6G, I think we can agree the environment is becoming so much more complicated, and what we are capable of achieving in a service-centric environment is still very much dependent on what that network is able to do in terms of its performance and reach and so on. So what is the role of the network operator moving into 6G? Is there still value in owning infrastructure? And if so, what should that infrastructure look like? And should it be dictated by the network operator or by the users of the network or by governments? So anyone want to jump in? There's a very long question. Feel free to take any part of that or tackle all of it. Anyone want to kick us off? In which case I might pick on someone. I might pick on you, Paul, as you were the most recent speaker. From a government perspective, governments don't move as fast as technology moves. So, you made some valuable points there about in 6G, how do we engage with governments? Is it a case of getting them to think about it and move quicker, or do we have to kind of put the brakes on the technology? How do we ensure that there's a little bit more synchronization as we set the framework and the context for 6G? And what's the role of the operator in there? How do they play the role? Because they pay governments huge amounts of money for spectrum.
Yeah. No, I think that there are several things that you can do. First of all, there is something like an educational thing, because let's be honest, when we talk about 5G, 6G, it's also pretty complex. So there's an educational effort towards policymakers who may not be completely versed into this. But the other thing that's very important is actually to present options that are driven from the requirements of government. So I liked actually the scenario that Hans-Jurgen gave of the crowd, and there's a clear public security challenge in that. So public security is changing its view, police will change its view. How do you do crowd control? And you wouldn't want to develop a systemic risk in a crowd that is getting together there. So what kind of architecture can you propose? What kind of options, and how do you then do the trade-offs? And explain this early on to policymakers, which will elicit also the other requirements that they have, because also their requirements are often quite complex and they have to deal with a legacy of legislation. There may be vertical legislation already in certain sectors that they cannot get away from. And that also needs to be explained, I think, to more technology and research oriented people. My personal experience is that this is absolutely possible. Nothing of this is too difficult to explain. But you need to invest in that. And I must say, I don't see that this investment is happening right now.
Okay, thanks very much. Anyone else want to come in on that?
Maybe to add a little bit more color, because your question, Richard, indeed is a relevant one, right? What is the role of network operators in the years to come? And let me start by saying very relevant from sustainability and quality as well as trust aspects. Why? Because when you look at architecture going forward, it's heterogeneous in many ways, right? So I would argue there's value for someone, a party like network operator, to really in a flexible way provide that cover of trust, as well as guaranteeing the correct and appropriate service level, and all that in a transparent and fair fashion. And that, of course, then links into technology that allows you to do that, which I don't think we touched yet upon as part of this discussion, but I think it's really key. It's one of the key architectural domains, Paul, that also probably is in the government's interests, namely orchestration. How do you smartly orchestrate across architectural domains, right, in an environment that's increasingly heterogeneous and complex? And by the way, when you touch upon that theme, that's also where players like Nokia can tremendously help, right? Because by definition, we kind of are really savvy in all these technology components and solutions, and we can empower various players, especially also network operators, to make such a paradigm happen. Not to mention all the relevant technologies to assure trust in the 30s per se, which is a topic in its own right.
Absolutely, thank you.
Oh, sorry.
Go ahead, Gavin.
Oh, sorry. So just to add on what Volker was saying, I do think I think the operators obviously have a fundamental role in just providing coverage and providing a certain level of service. And that's obviously a multi-billion-dollar, it must be tens of billions by the time 6G arrives, to sort of ensure that you have ubiquitous coverage and you are able to run services which are going to be more and more cloud dependent in the future. I think what's interesting about the operator role is then, I'm not sure where the cloud platform and the operators sort of, so they're starting to merge already. And so the question is, what is this platform then going to look like? I think it's obviously going to be very interesting to see how it has to get orchestrated based on new government regulations, and also how it gets orchestrated to enable these new kinds of services. But then the other thing about it is that it's also going to be, what's it called? It's also going to be, have to be open, or you're going to have to allow sort of other applications and servers to sort of into this platform in a way that allows you to make these services open to everybody and deployable. And I think that's going to be a very interesting way that this 6G evolves, and even 5G evolves in the future.
Thank you, Gavin. Anyone else want to come in?
Yes, Hans-Jurgen. I also would like to hook on the trust and security part, which I think is very essential for the different services. It's more and more data. It's also with the immersive media. Basically, if you would be sitting in a bank account and the officer there could see with augmented reality to your health records, I think it's a huge type of problem. This sort of sort has to be sorted out. I think with the network operator, the question, what are the services one could actually get revenue of, and one, for example, is equipment. That would be the storage, and would be definitely bandwidth if that is owned by the operators, and that might be other IT type of resources which would be not available, but also the trust and security could be provided by the operators.
Mm-hmm. Okay, Heikki, we've not come to you yet. Did you want to jump in?
Yes. Yeah. If the question is that what happens to mobile operators? How do they operate in the future? Maybe I would kind of speculate with the practical answer first. So I think they have strong assets in the spectrum licenses and in the base station network, and also fiber. It's hard to me to see that they would kind of surrender any of that. So even if they go to services, I can't see how they would forget the real physical reality. But then if I play with kind of some researchers' fantasy, and if I make the assumption that in the future we would have real tough competition in mobile environment, and every actor should really focus on their core competence, then I would see that the mobile operators, they really stick they become mobility operators. They stick to base stations and spectrum and take care of the mobility management and everything related to that. And then there would be another business role, another segment, which would be kind of fixed connectivity operators who can take care, IP operators who can take care of efficiently the national and international IP network. And then there would be separately user operators. So service operator who actually is the face towards the subscribers and knows how to handle the individual users and user segments and play with the service key. But this is my kind of two cents for speculation.
And that's indeed what we're here for. So thank you for that, Heikki. I think that it kind of touches on something that Volker mentioned about increasingly specialized network environments, and something that you've raised with me prior to today's discussion about the difference between the kind of nationwide networks, but also local network environments. And we're seeing a lot of activity around private or enterprise-driven 5G networks. Certainly there's a lot of activity there. One can only imagine that that kind of specialization is going to increase as we move into an even more complex and diverse 6G ecosystem of services and different requirements as there. Anyone want to kind of come in on what that means, that kind of level of specialization? And with that, is it really too much to expect network operators to be able to handle that? I mean, really, you know, we're already seeing the internet hyperscalers play an important role. We're seeing IT and computing specialists and software-driven organizations and systems integrators play roles. So this is a complex value chain. Really, are we talking about rebuilding the value chain for every different service environment almost? Any thoughts from anyone? Go ahead, Paul.
Yeah, perhaps just one comment about that. In a certain sense, you see in some sectors, you see kind of analogous developments happening where it's about how you play with the essential digital infrastructure that you have at your disposal as a business. And do you take care of that within your entity, within your company, within your organization, or do you outsource it and have it then operate separately? And today what you see is that when we talk about the way governments have been looking at it in terms of law, for examples, they impose rules either on you in this vertical business or on these digital infrastructures as a horizontal facility. They don't impose rules on the connection between the two. I think that's what we have to anticipate, because that's a connection which is, you know, in a certain sense, we are creating more flexibility to have that choice. Do you do it in-house or do you buy it from an independent provider? But then you need to arrange for the interface and what are the rules there. And this is a mix of a technical interface, a process procedural interface, and of course, certain legal contractual obligations that exist there. Well, I think there too, you can think about it. So how would you then design that? Also from a technical view, so that in a certain sense, it's the function that you can move around from inside your own company, whether you are the business user or to the outside. And if it is, why would there be different rules in terms of security, privacy, quality, performance, etc., when you are running it in-house than when you are having it provided from the market? And that's the interface part, which I think is underspecified at this moment. I think Heikki made some suggestions actually for that.
Okay, thank you, Paul. Anyone else want to offer a comment on that? Yeah, go ahead, Volker.
Yeah, maybe building on some of the aspects that Paul, you mentioned, I guess, one, let's be clear, there's a clear trend towards millions of subnetworks, specialized networks, and many of them increasingly neutral host, special venue. Right? Think of what we see happening with tower companies as an example. And I think this is exciting in a variety of ways. One, I think it's part of a trend towards sharing, smart forms of sharing as well, potentially. That's maybe one aspect. And that's, by the way, coming back to your earlier question, where operators have a natural role, because by design and mission, they are able to share by flexible orchestration means, such as slicing. On the other hand, yes, there is customers, especially in the industrial context, who after all go like, no, we want to have like industrial grade private wireless solution. And in some cases, they even go, I don't want network operator involved for what I do on the campus. Okay, we can also handle that. Like from Nokia perspective, we have specialized offering, digital automation cloud. So this can be done. But I think the exciting piece, Paul, is about how we connect wide area and private, and in the sense of value chain innovation and business model innovation. So what comes to mind is the example of you optimize production flow, like in the campus, in the industry setting, and then seamlessly you link into logistics, which is wide area kind of sector. And you know what? In Germany, half of the trucks, typically, they still go empty every single day. So something is broken. And by the way, we don't need to wait for 6G for that part, but interlinking value chain, wide area and specialized network kind of context, I think that's a powerful area to be explored a lot more. And it answers your question earlier, Richard. There's relevant role for the guys who do wide area and who are capable to do specialized at the same time. And there's lots of room also for specialized operations. And let's be clear, that's also very important. When you look at some of the performance attributes of 6G, they are by definition limited in range, right? You cannot cover every remote corner of the earth like 100 gigabit per second. It just doesn't make sense. It's not needed. So I think that's the other very important point. So it's not just the specialization aspect per se, but it's tailoring the offering to where it makes sense, customizing it. I think that was part of what I tried to say earlier as well, in a flexible, programmable way, and in an open ecosystem way, linking into software paradigm and APIs in the right fashion.
Okay, thank you. Good points, Volker. Thank you very much. I'm going to pick up on that. You know, what are those technical requirements? What are those network performance criteria for the 6G network domain, and what have we learned from 5G in terms of building some of those kind of more flexible, tailor-made capabilities from 5G? You know, are some of what we're talking about for 5G actually going to be more within the 6G roadmap, really? Did you want to come back on that, Volker?
It's a great question. So I think we see excellent momentum with orchestration, management, automation, solutions, including slicing. And yet, what you're getting at, Richard, I think it's true. When you look at previous Gs, there always consistently has been, like, some items have been very ambitious and they only fully deliver on what we commit in the next G. So if that's part of your question, it might happen. But you know what? Nothing wrong with that. I think it all starts with a vision, right? And I think for 5G, the vision had been bold, but for 6G in some key dimensions, it's even bolder. And I think we should come back to what the areas are where we go beyond what 5G can do. But clearly, softwareization, cloudification is on. Microservices architecture, as I've mentioned earlier, convergence of RAN and core, and flexibility, attributes, and orchestration. So let's see how it all pans out. But to highlight again, let's maybe focus on how the ambition with 6G would go beyond somewhat what 5G can do. I think it's this extreme level of densification. That's important. Why? Because that will allow us to really provide peak data rates beyond what we can do today, and for lots of concurrent users and sensors. And maybe that's one more element we haven't discussed yet. It's the role of devices and sensors in the 6G world, right? We will see billions of these, and they will tie into what 6G architecture is about, and thereby enabling truly use cases and impact in the context of transforming and saving the planet, I would almost say. Paul, you had earlier commented like all this outer space stuff. No, but the idea is we have tremendous opportunity and challenge. And so let's look at ways to help tackle some of these challenges. And I think sensing could be a part of that.
Absolutely. Thank you very much. Anyone want to come in on the back of Volker's comments?
Yeah, so just to add to that a little bit, I think clearly the platform is going to evolve significantly in the next 10 years. And I think that's obviously how it orchestrates, how it gets distributed is going to be sort of fundamental to how this works. I do think also to add to that is the role of data and analytics in this platform is going to become very important. So obviously how that network itself and the platform itself becomes more optimized in terms of how it works and how it provides service. And also then the handling of data is going to be a big problem or big issue to sort of figure out how to do, like where are you allowed to handle, how does regulation sort of affect where data is processed, and also how you make sure that the data is processed correctly, how do you offload or how do you manage the load between the device and the network. And I think that's going to sort of fundamentally change how the platform works and also how the network then gets orchestrated. And I think those things are some things that have to sort of evolve over time. It's going to take a while before we actually see that get manifested. I don't know if it's going to happen in 5G timeframe or something that's more likely to be more native to 6G. But I do think a more data-centric, service-centric design is something that we should be moving towards.
Yeah, and context-centric as well, presumably. Okay. Anyone else want to jump in? Heikki, go ahead.
Yeah. So I would like to combine the two comments from previous comments. So this densification and neutral host. So it is quite possible that this densification, because of 6G and the higher frequencies, leads to smaller cells. Smaller cells, which actually creates burden from kind of OpEx viewpoint, the costs, and also because it goes into properties, inside properties and campuses and factories, and also because it may change the, let's say, city atmosphere, depending on how the antennas are visible around. So there might be kind of city architect type of concerns about the aesthetics of things. And for instance, having 5G, 6G base stations on street light poles, it's one of the ideas of unifying and simplifying the digital infrastructure in cities. And that actually leads into this thinking of neutral host and sharing even more. So there might be pressures coming to share more on the base station area, not only sites, but also kind of electronics. And that raises the question that how the spectrum licenses will be allocated. Is it actually operators, or is it those property owners or those who have immediate interest on street light poles and so on? And if that happens, then that may lead into more service-centric behavior also from mobile operators.
Yeah, and that's something I think that touches on the value of that infrastructure, but also the responsibility for it as well. Then we've seen already a trend towards RAN sharing within mobile operators that arguably suggests the value is not necessarily in owning and deploying every element of that network, but in having access to it and marketing access off the back of that. So yeah, it kind of suggests there could be a sort of subdividing of the network operator into different business units or different responsibility areas in a more formal way than there is already, perhaps. I don't know if I'm taking your point correctly, Heikki.
Yeah, more or less.
Okay, more or less. Okay, that's great. So when we're looking at the change in the value chain around operators and service providers, we need to have a bit of a rethink around the way we set policy, the way in which spectrum's allocated, the way in which government activity kind of not controls this, but enables this environment, and how technology enables government as well, perhaps. So just picking up on a question that we've had in from the Q&A, and I think it touches on some of the points of discussion we've already had. Should this be more at an international level? Should this be, aspects like radio spectrum allocation? Should there be more neutral roles within the landscape for, if you like, has been suggested by one member of the audience, a kind of traffic cop, kind of overviewing and a kind of ombudsman role? What happens on a network? What is fair use of that network when there's so many users and so many different service environments? Do we need that? Do we want that? Is it going to give a better user experience, or is it going to tie us up in red tape a little bit? Any thoughts?
Well, my quick reaction would be, Richard, if I may, probably the best option we would have is to put humans in control, right? So that's probably, and it's what also I think I had in mind when I said expanding human possibilities. I think we need to make sure that we start from individuals and the rights that individuals have in civil society in Europe, and that's, I think, probably the right starting point. The other aspect, I guess, is indeed how we collaborate, and this is a discussion on service centricity for the 6G era. And I think to get technology right, and then with also kind of going in step with what regulators do and governments do in terms of framing the legal framework, what I would like to highlight also is some of the instruments as we currently use to do that. So think of the HexaX flagship project sponsored by the European Union. We at Nokia have the lead with that. I think it's one such powerful vehicle, right? It's not just framing the research agenda jointly, but it's working with, in this case, key stakeholders in the Commission, in the governments, and of course with the consortium members, all of them, right, from academia, industry, SMEs, and then I think making sure that we all agree also, not just on the technology part, but in terms of what is it that we truly try to achieve. And as I said, I think it starts with putting human in control as a central thought, and making sure we don't compromise on the values that we have in Western society.
Very good. Okay. Paul, did I see you raise a hand? Yes, go ahead.
Yeah, I find that question about how you can operate internationally extremely relevant and interesting, because so much is happening actually internationally. I mean, Volker is referring also to international projects that have a fairly wide participation, perhaps nowadays a bit less wide than it used to be in the 4G or 5G development, but still As also was referred to the open internet development by Heikki earlier, all of these truly global developments, yet to some extent they did not deliver. Because this global open approach is very, very hard to sustain or already broken up. We've got a fragmented internet. We've got these great concerns around 5G security. We've got a lot of mistrust around what is happening in capturing in terms of, for example, IoT. And so I think that I would love to see that someone spells out how can you get a path to maintaining a global approach. In other words, you will have to argue, and I wrote an article about that, that more or less argues if we don't fix 5G governance, we are not going to get a global 6G, we get a fragmented 6G. If we don't fix it now, we may not be able to maintain the more ideal, also technically ideal, and from a business perspective more, and from a citizen perspective, to come back to what Volker said, more ideal approach of a global approach. And we'll have to clarify that the technological solutions that are found are not going to actually compromise, for example, national sovereignty or national security. And explaining that, that story is not being told. I must say, personally, I'm convinced actually that governments better fight out their sovereignty battles on something else than 5G or 6G. There are so many other places that you can do the geopolitical game. If the 5G, 6G community can maintain and strengthen a global approach, that would be a tremendous asset. But I'm not very optimistic that they can.
Thank you, Paul. Anyone else want to come in on that? Okay. So we are into our last few minutes. So just rather than ask a last question, what I'm going to do is go around the panel and give each of you just kind of 30 seconds to a minute or so, just to kind of say if there's one thing that you could leave our audience with in terms of a thought for the day, something to take away and think about, or a point that you would like to make. If there's one thing, what would that be? And who's brave enough to go first on that? Everyone else wants a little bit more thinking time, I can see. Okay, Gavin, I thought I saw a hand go up, so I'm going to.
I guess I'll take this. So yeah, I mean, I think one of the things that I've been speaking about internally, and I think it's also important for us to understand, if we looked at 4G at this stage and we were starting to design 5G, we would have missed a lot of things. Slicing was not there. Just the fundamental idea of cloud. We hadn't even looked at the concept of deploying an unlicensed V2X and sidelink kind of technologies did not exist at this stage, equivalent stage in 5G, so in 4G. And so I think one of the things we should understand is that there is going to be new technology and new ideas that are going to evolve in the next few years that are probably going to fundamentally shape 6G. And those are things that we also probably need to start looking at and sort of figuring out what's going to happen. And I think that's also, so what we expect now for 6G could be very, very different for what actually happens in the next 5 years or 10 years.
Yeah, good point, Gavin. And it's maybe in the hands of those who come along somewhat younger than us in years to define what we do with the networks we're building. Thank you, Gavin. Anyone else want to jump in on that?
Perhaps just a brief comment from my side. I think it would be very useful to continue explaining a number of usage scenarios. Although I fully agree that, you know, lots of what is possible we don't know, because the technology will enable all kinds of things that we cannot even imagine. Yet we are, I think, already in a stage, and you were mentioning some usage scenarios that are quite well explainable and then can be thought through in terms of what does this mean. For example, the question about spectrum, this question about the technology architecture versus security and privacy, the question of who has an opportunity here to become a dominant player or not, those kind of things you can actually hook into the usage scenarios. That's a fruitful thing, I think, to have the dialogue with policymakers.
Great, thank you very much, Paul. I'm going to come and pick on someone else. Heikki, thought for the day to wrap up.
Okay, final words. So yeah, I would actually bring up the same thing as I bring up to my students often. And now that we are looking into the future of mobile platforms, it's obvious that we are seeing kind of more dynamics and turbulence on technical architectures. And we are also seeing kind of turbulence on value networks and the structure of the ecosystem. And the same thing that I mentioned earlier, this kind of new linkage between the technical architectures and the business architectures. This is something that is valuable to think when looking into from 6G to 5G to 6G. And actually, whether you are a business person or a technical person, this is important. You need to somehow look over the border to see how things evolve.
Okay, thanks very much. Hans-Jurgen.
Yes,
final
the
comments.
final comments is, I think one also should learn from the 5G when one moves over to the 6G in terms of sustainability, which we don't have discussed here. I think with 6G, we also have a unique opportunity to include in the development of such new systems sustainability. I would call it the sustainability 6G environment with all the different type of applications. One have the different network slices and all the players involved. So I think that would be my last comments.
Thank you very much. And important point there on sustainability, which is worthy of many panels and conferences in its own right. Mm-hmm. Volker, just finally to you to wrap.
Thank you, Richard. So indeed, the opportunity is upon us. I think it's a great opportunity to discuss, shape, frame the research agenda for the next generation of communication networks. My final thought is all about service centricity, driving growth and sustainability, efficiency objectives, serving mankind in the best sense of the word. I think that's at the heart, and probably this goes hand in hand also with, once again, highlighting the importance of cooperating, collaborating, and there's value in standards. There's value in standards, and it all starts with the air interface. It's obvious interoperability is important, but it's also important, I believe, in the interest of everyone on this planet, that the best ideas from research make it into a standard, and therefore in this way we define the best possible scenario for the next generation of networks.
A great point to finish on. So let's all work together to make it happen to the best possible outcome for all of us. Thank you. I'm going to wrap there, gentlemen. It's been a pleasure, and I really do appreciate your contributions. I'd like to thank Gavin, Volker, Heikki, Hans-Jurgen, and Paul for their commitment to the panel and their contributions today. I'd like to thank 6G World for putting on the 6G Symposium. I think it's been a really fascinating and stimulating conversation, and you can watch the archived version online. It'll be posted shortly, I believe. So thank you once again, and I hope it's been useful. We've jumped around lots of topics, but please do follow up with 6G World and let them know what you thought of what we put together for you. But for today and for now, thank you very much and goodbye.